For part A of question 1, I'll need the class with the highest frequency. Now the highest frequency is 19, so the modal class is between 48 and 54. So 48 less than S less than or equal to 54. Now for part B, I will need to construct 2 more columns. Now in the first column, I'll write midpoint and I will label this as X. Frequency, I'll use F for shorthand. And in the last column, I'll multiply F by X. Now the midpoint of these 2 numbers is 33. You add them and then you divide by 2. The next one is 39, 45, 51, and 57. And then for the last column, you just multiply F by X. So I get 132, 546, 810, 969, and finally 285. The formula for the mean is the following. Sigma fx is the sum of the column labeled fx, and this is equal to 2742, and sigma f is the sum of the column labeled f, which is 60. We're given this in the original wording of the question. So if I substitute these values into the formula, I will get 2742 divided by 60, and this gives me an answer of 45.7 centimeters. In question 2, I need to find the total surface area of this triangular prism. Now this is made up of 5 shapes. I've got 2 triangles, a rectangle at the base, a rectangle standing vertically at the back, and a rectangle which is diagonal. So now I'm going to extract those 5 shapes, find the area of each, and then add them up. For the blue rectangle, I will need to find the width, and the width is this diagonal here. I'll find this using Pythagoras theorem. Let's label this x. So x squared is equal to 4.8 squared plus 3.6 squared. If you add these squares and then take the square root, x will come out to be 6. So if I put the dimensions on these shapes, they're going to look like this. So area equals to the 2 triangles, so 2 times 4.8 times 3.6 over 2 plus the area of the green one, 3.6 times 7, plus the area of the red one, plus the area of the blue one. Put this on the calculator and you'll get an answer of 118 centimeters squared to 3 significant figures. In question 3, I'm given that the range is equal to 9. Hence, if I take the biggest one, subtract the smallest one, this must be equal to 9. Hence, x comes out to be equal to 3. Now, the median is equal to 8. That means if I take the middle 2 numbers, add them up and divide by 2, I should get 8. So y plus z over 2 is equal to 8. So y plus z must be equal to 16. Finally, the mode is equal to 10, which implies that there must be at least 2 tens. Hence, z must be 10. Thus, y is equal to 6. So we have x equals to 3, y is equal to 6, and z equals to 10. For question 4, I'll use the formula that says that the final amount is equal to the initial amount times a multiplying factor, and I'll do that for both offers. Now for the first offer, I have a reduction of 16%, which means that the multiplying factor is given by 100 minus 16, which is 84 over 100, and as a decimal, this is 0.84. Hence, final amount is equal to the initial, which is 1,600 times 0.84. This gives me 1,344. Now for the second offer, I have a reduction of k%, so the multiplying factor is equal to 100 minus k over 100. So 1,344 is equal to the initial amount, which is 1,400 times my multiplying factor, which is 100 minus k over 100. And now I'll need to solve this equation. Now, if I rearrange by taking the 1,400 with division to the other side, I will get 0.96 equals 100 minus k over 100. Then I'll take the 100 to the other side by multiplication. So 96 equals 100 minus k. And if you rearrange now, k will come out to be 4. And this is the final answer. For question 5, the largest share is 8 and the smallest one is 2. Now the difference between the largest and the smallest is equal to 6. So I know that 6 parts is equal to 390 grams. Now for the total, I have 2 plus 5 plus 8, which is equal to 15 parts. So 15 parts is equal to 6 grams. And to find C, you'll just cross multiply 15 times 390 over 6. Put this on the calculator and you will get 975 grams. I can solve question 16 either by using elimination or by using substitution. I'll proceed with elimination, so I'll multiply the first equation by 3 and I'll keep the second one the same. So I get 3x plus 6y equals to 45, and the second one stays the same. Now, in order to get rid of the 6y and minus 6y, I will add, so these two will cross out and I get 7x equals to 49, so x is equal to 7. You can substitute this into any of the two equations. I'll select the first one, so I get 7 plus 2y is equal to 15, so 2y is equal to 8y comes out to be 4, so 7 and 4 is the final answer. Part of question 7 is 0.0000932. For part B, I'll keep the first number the same and I'll rewrite the second one as 0.6 times 10 to the 5. So both numbers now are times 10 to the power of 5. 3 minus 0.6 will give me 2.4 times 10 to the power of 5. And then for part C, I will multiply 3 times 6, which will give me 18 times 10, and then I will add the powers, and this will give me 120. Now, this is not in standard form. I will take a power of 10 from the 18. I'll pass it to the 10 to the power of 120. So I will get 1.8 times 10 to the 121. For question 8, part A, the common factor is 3c squared. and then you get 6cd squared minus 7. For the second one, the two factors are y minus 6 and y plus 3. And if I equate this to 0, the two y values I will get are 6 and minus 3. For question 9, I will divide the isosceles triangle into two right angle triangles. Now, the perpendicular line from C to A, B is the height, so area equals to base times height over 2. So 42 equals to 7 times height over 2. Height comes out to be 12, and then using any of those two right angle triangles and Pythagoras theorem, you can find y. So y squared is equal to 12 squared plus 3.5 squared. This comes out to be 625 over 4. So y is the square root of that. That's 25 over 2. As a decimal, that's 12.5. And that's my final answer. In question 10, M is the midpoint of RT, so RM equals to RT. Now I will join OT. The triangle ROT is isosceles, so RO equals to TO. And because the point M is the midpoint of RT, it means that RMO is a right angle triangle. And I will use the right angle triangle RMO for my calculations. So from this triangle, sine of 52 equals to opposite, and the opposite is half of 12, so that's 6. So 6 over R. If I rearrange to get R on its own, I'll get R equals to 6 over sine of 52. Put this on the calculator and you'll get an answer of 7.6141 and so on. And then to find the area of the circle, I'll just use the following formula. Let's plug in the values. This will give me pi times 7.6141 ... square, and this comes out to 182, correct to 3 significant figures. For part of question 11, we just find the cumulative frequency. Now the first one is 7, and 7 plus 10 is 17, plus 15 is 32, plus 32 is 64, and plus 16 gives me 80. In part B, I need to draw a cumulative frequency graph. Note that all times start from 0, hence the x-intercept will be 0. Thus the graph passes through the origin, and the coordinates are made up of the x-coordinate being the upper bound of each category and the y-coordinate being the cumulative frequency. So these are the coordinates I have to plot. So let's go on the next page. Now I'll zoom out to fit the whole grid on a single page, and I'll start by plotting these points, and then I will join the points using either a smooth curve or straight line segments. I'll go with the second one, and this is how it looks like. So let's go to part C now. Use your graph to find an estimate for the median. I have a total of 80 patients, so 80 divided by 2 is equal to 40. So I'll go on the y-axis at 40 and find the corresponding x value. And as you can see, I get a value of approximately 32.5, and that's our median. Note that the mark scheme accepts values in the range 32 to 34 minutes. For the interquartile range, I'll first find Q1. A quarter of 80 is equal to 20, so I'll need the 20th observation. And Q3 is equal to 3/4 of 80, which gives me 60, so I'll need the 60th observation. So I will work in a similar way as I did with the median, but instead of finding the values of 40, I'll find the x values that correspond to a cumulative frequency of 20 and 60. So as you can see from the graph, these values are 22 and 39. So the interquartile range is equal to Q3 minus Q1, and that gives me 17 minutes. Again, note that the mark scheme accepts any value between the range 15 and 17. For question 12, I'll keep the left-hand side the same. I'll rewrite 32 as 2 to the power of 5. So now I can equate the powers and get minus 4x equals to 5. So x is minus 5 over 4. You can write this either as a fraction or as a decimal. For question 13, let x be equal to 0.38181 and so on. So we are repeating the 81. Note that you can move the decimal to where this pattern begins by 1 decimal place. So basically this is 10x, and this pattern ends 3 places after the decimal. So we get here 1000x. So what I'm going to do now is write 1000x equals to 381.81 and so on, while 10x is equal to 3.81 and so on. So now I have 2 decimals where the numbers after the decimal point are exactly the same. So if I subtract, I'll get 990x is equal to 378. Hence, x equals 378 divided by 990. This simplifies to 21 over 55 as required. For question 14, I'll first find the lower and upper bound of P. So P is between 0.505 and 0.515. I also do the same for R. R is between 6.25 and 6.35. Now, since I want the upper bound of T, I'll use the upper bound of the numerator and the lower bound of the denominator. Hence, I'm going to use the 0.515 and the 6.25. So let's substitute 0.515 over 6.25. Put this on the calculator and you will get 0.0824. For part A of question 15, I'll calculate the missing y coordinates, and these are 0, 2, and 4. For part B, I'll start by plotting these points on this grid, and then I'll join them using a smooth curve. For part C, I need to rearrange this so that the left-hand side becomes the equation that I have plotted, which is this one So the first thing I will do is divide this by 2. So I get x cubed minus 1.5x plus 2 is equal to 0. And now I need to have a minus 3x on the left hand side instead of a minus a half x. So I will subtract minus a half x from each side, and then I would add the left hand sides and the right hand side. So on the left hand side I get x cubed minus 3x plus 2, and on the right hand side I get minus 1.5x. The equation y equals left hand side is the one that is already plotted on my grid. What I need to plot now is y equals minus 1.5x, and to do so I will create a small table of x and y values. I'll randomly put for x minus 1, 0 and 1. I'll calculate the corresponding y values, and these are 1.5, 0 and minus 1.5. So now I'll go to my grid and plot these points and join them using a straight line. As you can see, the two graphs intersect at a single point, and the x-coordinate of that point is minus 1.7. So that's my solution, minus 1.7. Note that the mark scheme accepts minus 1.6 as well. Note something very important here. According to the mark scheme, you must not give the y-coordinate, otherwise you will lose the last mark. This is because the instruction says solve this equation and not find the point of intersection, so we only need the x-coordinate. For part A of question 16, just replace x with a third. So you get 2 over 3 times a third minus 5. Put this on the calculator, the answer comes out to be minus 1 over 2. For part B, consider that I have y equals 2 over 3x minus 5. So instead of f of x, I wrote y. Then step 1, replace y with x and x with y. So x equals 2 over 3y minus 5, and the target is now to make the y the subject. So I will start by cross multiplying. So 3xy minus 5x equals 2. I'll continue on the sides. 3xy equals 2 plus 5x. So y is equal to plus 5x over 3x, and that's the final answer. I still need to write it here so it's in the form f of x equals and not y equals. Part C is independent of parts A and B. I have a new function and I need to express it in this form. So basically I'll need to complete the square. I'll start by taking out a common factor of 5 from the first two terms. So 5 square brackets x squared minus 4x, close the square bracket, plus 23. And then for the expression inside the square brackets, I'll need to complete the square. The formula I'm going to use is the following. So just for the expression inside the square brackets, I'm going to have the following: x squared minus 4x equals to x minus 2 squared minus 2 squared, which simplifies to x minus 2 squared minus 4. So now I can replace the blue expression with x minus 2 squared minus 4 plus 23. Now I'm going to expand the square brackets. This gives me 5 5x minus 2 squared minus 20 plus 23. And if you simplify this, you will get 5x minus 2 squared plus 3. In question 17, I'll need to use the following two formulae. The first one is the area of any triangle. The second one is the cosine rule. So using a formula similar to the first one, but with rearranged letters, the area is equal to 1 over 2 AC times sine of angle B. So 12 equals to 1 over 2 times 8.3 times 4.6 times sine of B. So sine of B is equal to 12 divided by 1 over 2 times 8.3 times 4.6. Put this on the calculator and you'll get sine B is equal to 0.6286 and so on. So B is the inverse sine of this number. B comes out to be 38.947 and so on. So now I can use the cosine rule to find AC or lowercase b. So the version of the cosine rule I'll use is the following. B squared equals to a squared plus c squared minus 2ac cos of angle B. So B squared is equal to 8.3 squared plus 4.6 squared minus 2 times 8.3 times 4.6 times cos of angle 38.947 and so on. B squared comes out to be 30.66 ... Take the square root of that. B is 5.537 and so on. So finally, to find the perimeter, we'll just need to add 4.6 plus 8.3 plus the value of B we found, and this comes out to be 18.423 significant figures. I'll start question 18 by expanding the brackets on the left hand side. So x square root of 3 minus 2 square root 3 square root 3, which gives me 3, equals to x plus 2 square root of 3. Now I'll take the x on the left and the number on the right. So x square root of 3 minus x equals to 6 plus 2 root 3. I'll factorize the x on the left hand side, so x square root of 3 minus 1 equals to 6 plus 2 square root of 3. So x equals to 6 plus 2 root 3 over square root of 3 minus 1. Now you can put this on the calculator and get a rationalized form, but because the question says show your working clearly, I have to show how I rationalize. So multiply both top and bottom by square root of 3 plus 1. So if I expand at the top, I will get 6 square root of 3 plus 6 plus 2 square root of 3 times square root of 3 is 3 plus 2 square root of 3, and then in the denominator I get square root of 3 times square root of 3, which is 3, plus square root of 3 minus square root of 3, this cancel out, minus 1, hence x equals 8 square root of 3 plus 12 over 2. Let's split this into 2. So 8 square root of 3 over 2 plus 12 over 2, which gives me 6 plus 4 square root of 3, and this is in the required form. In part of question 19, I have that p is inversely proportional to y squared. So p equals to k over y squared. I'll substitute the values of y and p I am given. So a is equal to k over 4 squared. So a is equal to k over 16, which implies that 16a equals to k. Hence, p equals to 16a over y squared. In part B, we are given that y is directly proportional to the square root of x. So y equals to k square root of x. Note that this k is not the same k as in part A. Now from part A, I know that p equals 16a over y squared, so I can replace the y with k root x. So p equals 16a over k square root of x squared. So p equals 16a over k squared times x. Now I'm going to substitute the values of x and p I'm given in the question. So 4a equals to 16a over k squared times a. I'll cancel out the a's. So to find k squared, I'll just cross multiply. K squared is equal to 16 over 4a. Divide top and bottom by 4. This comes out to be 4 over a. So p equals to 16a over k squared x. K squared is 4 over a. I'm going to multiply both top and bottom by a to simplify. So this will give me 16a squared over 4x. Simplify the 16 with the 4, so you'll get 4a squared over x, and that's the final answer. P equals 4a squared over x. For question 20, I have a transformed version of the cosine graph. Now, the a at the front is stretched by a scale factor of a, so practically you multiply the y coordinates by a, and the plus b inside the bracket is a translation by b units to the left, so b to the left. Now to find the values of a and b, let's consider the original cosine graph. Note that the height goes from -1 to 1, so it has a total height of 2. Consider the minimum point. The minimum point is here at 180 minus 1. So if I go to the transformed graph at the top, note that the height of this one is equal to 4. Hence, the graph has been multiplied by 2, which implies that a is 2. Furthermore, the minimum point is now at 45 minus 2. So it has moved from 180 to 45, and this movement is 135 to the left. Hence, b is equal to 135. I'll start question 21 by using triangle ADE. And using this triangle, I'll find side AD. So let's extract this from the shape. So tan 18 is equal to 2.2 over A and D. So A and D is equal to 2.2 over tan 18. Put this on the calculator, you'll get 6.77 and so on. Next, I'll take the rectangle at the base, ABCD, divide it into two and construct two right-angled triangles, and I'll use the right-angled triangle ABD. And from this triangle, I'll find the diagonal BD. So again, let's extract this from the shape. So using Pythagoras theorem, BD squared is equal to 6 squared plus 6.77 and so on squared. BD squared is equal to 81.845. Take the square root, this becomes 9.046 and so on. And finally, to find the angle between BE with the plane A, B, C, and D, I'll use the following triangle. Let's extract this triangle as well. So using the tan ratio again, tan of angle B is equal to opposite over the adjacent, which is 9.046 and so on. B is inverse tan of this fraction. Put this on the calculator and you'll get 13.7 degrees to 1 decimal place. For question 22, let's put some colors. Vector A is the red one, vector B is the blue one. Now I'm given that M is the point on OB such that OM to MB is 4 to 1. Hence, OM is 4/5 of B and MB is 1/5 of vector B. I'm also given that N is the point on AB such that AN to NB is 3 to 2. So BN is 2/5 of whatever vector that is, and NA is 3/5 of that vector. And then I have that OA to A is 5 to 3. So OA is 5/8 of the whole thing, and AE is equal to 3/8 of the vector OE. So for part A, I need to find ON, and this is equal to OB plus BN. OB is simply lowercase b, and BN is equal to 2/5 of BA. So lowercase b plus 2/5, and now I need to find BA, and BA is simply BO plus OA. And I can replace the vector BO with minus lowercase b, and I'll replace OA with lowercase a, and then it's just algebra. I will just expand minus 2/5 b plus 2/5 of a, and if I simplify, ON is 2/5 of a plus 3/5 of b. Now for part B, I need to show that MNE is a straight line. I'll need to work with 2 out of the 3 following vectors, MN, ME, and NE. I will work with the last 2. So ME is equal to MO plus OE. Now I don't have OE, but I'll come to the side and say that 5/8 of OE is equal to a single A. So if I divide by 5, I'll get an eighth of OE is equal to a fifth of A. So OE is just 8/5 of A. So if I go to the left now, MO is equal to minus 4/5 of B plus OE, which is 8/5 of A. I can factorize this and can take out the common factor of 4/5, and I will have in the bracket 2A minus B. Next, I will find NE. This is equal to NO plus OE. Now, NO is the reverse of ON, which we found in part A. So this is minus 2/5 of A minus 3/5 of B plus OE, which is this vector here. So plus 8/5A. Let's simplify. This is 6/5A minus 3/5B. And if I factorize, I'll get 3/5 2A minus B. So what I have shown now is that the vector ME and the vector NE are parallel, and they also have a point in common, that's point E. So MNE is a straight line. I can write this as a conclusion. For question 23, I'll make a rough sketch of the situation. No axes are required. Q is the line I need to find, so I'll start by differentiating. So dy dx equals 2, and now I'm going to bring the power down, multiply by 8, so I get 16x minus, and then the power on 14x is 1, multiply by 14 to get 14x to the 0, so just 14. So at point G, I have dy dx being equal to 10. I'm told that in the question, which implies that 16x minus 14 is equal to 10 for some value of x. 16x equals to 24, so x is equal to 3/2. That's the x coordinate of G, and since G is on the curve, I will substitute this value into this equation to find the y coordinate of G. So y equals to 8 times 3/2 squared minus 14 times 3/2 minus 6 gives me a value of minus 9, which implies that point G is 3/2 comma minus 9. Now for line Q, I will use the following rule. When you have perpendicular lines, M2 is equal to minus 1/M1, and because the gradient of the blue line is 10, then the gradient of the red line, line Q, is equal to minus 1/10. So y equals mx plus c. Minus 9 equals to minus 1/10 times 3/2 plus c. If you solve this, c comes out to be minus 177/20. Hence the equation of the line is y equals minus 1/10x minus 177/20. Now I need it in the form ax plus by plus c equals 0, where a, b, c are integers. So I'll multiply everything by 20. 20y equals minus 2x minus 177. And then I'll take everything to the left, and I will get my final answer, which is 2x plus 20y plus 177 is equal to 0. For question 24, I'll need the formulae for the nth term and for the sum of the first n terms. Now, for this sequence, A is equal to 8 and D is equal to 11. Now note that the last term is the term at position K. So let's find this last term equals, and using the formula A plus n minus 1D, I'll substitute and get 8 plus K minus 1 times 11. If I expand and simplify, this will give me 11K minus 3. So my sequence now has the following terms: 8 plus 11 is 19, and so on. And then towards the end, I have a few terms ending with 11K minus 13. And note that each time I am adding 11. Now, if I write this sequence in the reverse order, I will start with 11K minus 3, and I will end up with 19 and 8. And note that this time I am subtracting 11 from one term to the other. So, if I want the sum of the last 20 terms of the original sequence, this is equivalent to finding the sum of the first 20 terms of the reverse sequence. So now I can use the formula for the sum, but this time A will not be 8, A will be 11K minus 3, and D will not be 11, but D will be minus 11. So using the formula for the sum, I get n over 2, 2A plus n minus 1 D is equal to 10,170. So let's substitute 20 over 2, 2 times 11K minus 3 plus 20 minus 1 times minus 11 equals 10,170. So 10 equals to 22K minus 6 minus, now this bracket is 19 times minus 11 will give me 209 equals 10,170. Now I can divide both sides by 10. So this will give me 22K minus 215 equals to 1,017. 22K comes out to be 1,232. So if you divide this number by 22K, comes out to be 56. Now, in the mark scheme, they suggest another method that basically does the following. Writing my sequence, I've got 8, 19, and then at the very last, I have an unknown number. Now, if I go backwards, this is at position K, then the previous in K minus 1. And if I want 20 terms, I'll have to stop at position K minus 19. So using the formula for the nth term with A equals 8 and D equals 11, the K minus 19th term is equal to A plus n minus 1 D. And if you expand and simplify this, you will get 11K minus 212, and that's the term at position K minus 19. So now, if I add all these numbers, I should get the required sum. And note that for this sequence, A is no longer 8, but A is 11K minus 212. D remains 11, and I have 20 terms. So the sum is given by 20 over 2, 2 times 11K minus 212 plus 20 minus 1 times 11 So 10,170 equals 10 times 22k minus 424 plus 209. Again, cross out the 10 and divide 10,170 by 10. This gives me 1,017 equals 22k minus 215. And if you solve this, you'll get k is equal to 56, same as before.